each and every one of you to our weekly interaction program. As we gather here today, we embark on a journey of exploration and discovery into the realm of sustainable energy, particularly focusing on the evaluation and application of solar energy in India. So, this is an interaction event that will be held up to March 31st on every weekends of Saturday in the between 6 p.m. to 7 p.m. Now, I invite Harshini to give a brief introduction about the chief guest.
Good evening, everyone. It is my honor to introduce our esteemed chief guest, Sivaraman P., a young dynamic engineer. Sivaraman P. possesses a wealth of expertise in power systems with a particular focus on renewable energy integration, grid impact analysis for EV charging infrastructure, and power quality analysis. As a dedicated member of various IEEE standards and task forces, including IEEE and IEEE 2844, Sivaraman contributes significantly to shaping industry practices and ensuring the reliability and efficiency of our power systems. His involvement in national study committees of SECI further underscores his commitment to advancing power system technical performance and active distribution systems. And proficiency in simulation software such as ECHAP, PSCAD, MATLAB, and more, Shiraman brings a hands-on approach to problem solving and analysis, ensuring the robustness of a solution. Not only is Shiraman an engineer, senior member of the IEEE and a member of the Institution of Engineers, but he also holds the prestigious professional engineer certification. IEEE initiatives, including smart cities and PES YP powering the future, reflects his dedication for fostering collaboration and knowledge exchange within the industry. Thank you.
Now, it's time to welcome the office bearers of IEEE ADSF sites. We are J. Angelan Indra, past immediate chairman, and Professor J. Bino, chairman, Professor Dr. Nityavati N, vice chairman, Dr. Shanmugapriya N, secretary, K. Ajit, joint secretary, J. Pearlson David, treasurer, Mr. Sivaraman P, excom of projects, Dr. G. S. Uday Kumar, IEEE ADSF site coordinator, Professor Dr. M. Murthy, IEEE ADSF site organizer of North Tamil Nadu, Dr. G. Anandi, IEEE ADSF site organizer of South Tamil Nadu, Dr. A. Meyyappan, IEEE ADSF site organizer of East Tamil Nadu, Dr. S. Sasikala, IEEE ADSF site organizer of West Tamil Nadu, Mr. Darkesh, lead of social media, Ms. Catherine Mero, a special invite, and Professor Benisha M, special invite. I welcome all the office bearers of IEEE ADSF sites. Thank you.
Request Mr. Sivaraman sir, please start your session, sir.
Yeah, good evening, everyone. Thanks for the brief introduction. Yeah, so let's start our today topic. Let me share my screen. Please let me know once my screen is visible to everyone.
Yes, sir, it's visible, sir.
Yeah. Thanks for your confirmation. And I will point the laser pointer. Yeah. Very good evening to everyone and all present in this first online interaction section of IEEE ADSF site on evaluation of solar energy in India. So this is the first session I'm taking for IEEE ADSF site. Myself, Sivaraman. I'm one of the senior member of IEEE and the project director of the IEEE ADSF SIGHT and also IEEE PSYP IND subcommittee member. So in this presentation, we are going to see about the various solar PV systems, introduction about the solar PV systems and solar PV solar power in our India and the solar energy organization. So for our India, there is a dedicated ministry called Ministry of New and Renewable Energy Sources, and there are several research and central government organizations are there for solar energy and a glimpse of a large scale solar power plant. It's a 300 megawatt solar PV power plant. So these are all the things we are going to see. This is the very basic of solar energy session. In the coming session, we can I will let you go through the details and the technicals behind the solar PV system. So in this one, it is very basic session. Stay tuned and keep every week attending this program to get familiarized with various solar technologies. Yeah, I'm skipping the introduction part because it is already covered, and I would like to highlight that very recently we have authored a book for fast charging infrastructure for electric and hybrid electric vehicles. It was published by Wiley IEEE Press in 2023. So before going into the solar PV system and I would like to highlight upon the application of solar power. So mostly we are all know that the solar is mostly used for the electricity generations. So in addition to that, the solar power is used for various applications like solar heating and rural electrification. So the locations where the electricity is not reached, those locations solar is one in simple words we can say solar is a mini god, we can say. So the power we are getting from the solar is used to power the equipments in very remote areas and solar based street lightings and solar based water pumps. So in solar based applications we can segregate these applications into two categories. One is solar PV based and solar thermal based. So here solar electricity generation, rural electrification, solar street lighting and solar pumps are mostly solar PV based, and solar heating alone is solar thermal based. And moving upon, going into the solar PV system, the solar PV system, it's also called as solar photovoltaic system. So photovoltaic in short form, it is called as PV, and the system is used to produce the electric energy. So the main components of the solar PV system is a solar panel and the DC distribution box. So the various solar panels of series parallel combination is come to the distribution box. From the distribution box, a single or a couple of positive and negative outputs will go to the inverter, and the inverter will convert the DC electricity into the AC electricity, and finally it will go to the grid to the AC distribution box. So here the solar panel is made up of silicon based cells. Mostly there are certain technologies are there in solar PV panels that we will see in our upcoming sessions. And in the DC distribution box there will be a fuse and there will be an surge protective device. that is simply called as SPD. Then solar inverter. Solar inverter is a power conditioning unit. So that unit is used to convert the DC electricity into the AC electricity. So most of our equipments are nature of AC electricity. So inverter is used to convert that DC into the AC. And in AC distribution box, it having the fuse or MCB as a circuit breaker, and there will be an SPD such productive devices in the AC side as well, and there will be an energy meter to monitor how much amount of generation is produced from the solar PV system. Uh, if you have any questions, you can unmute yourself and you can ask then and there. Instead of waiting to ask the entire question at the last, then and there you can unmute the mic and you can ask the question. So about the block diagram, in simple solar PV system block diagram, it consists of the solar PV panels. So when combining multiple panels, we can say it is a PV array. Then inverter or power conditioner. In between, the DC distribution box will come at this location between the solar PV panel to the inverter, and the AC distribution box is here. So the distribution panel mentioned in this block diagram is simply the AC distribution box. If we are having a localized load to power, then from the panel we can connect the AC loads. If we don't have any AC loads, then we can export the power to the utility. So utility means electric grid. So about the solar PV panels, in the left side the left side photo, what you are seeing is the solar PV panel which is installed on the rooftop of the building. In the right side, what you are seeing is the solar PV panels is installed in the railway station shed. There is a shed in the railway station. So in that railway station, the solar PV system, including the panels, were installed. And the DC distribution system, so what you are seeing in this photo, it's a typical solar DC distribution box. It consists of a fuse and SPDs. So oh, so it is installed here. Uh, these three black color box is SPD, and these are all terminal blocks. Okay, so here the positive and negative terminal from the solar PV panels will come inside here, and the combined output will go to the inverter. Then moving upon the inverter, here I have given two inverters. The left side one is the solar string inverter. It's from Delta make, and the right side one is the right side one also the string inverter. This is Sungrow make. So upon the inverter, there are three different types of inverters are there. For the grid connected application, one is the central inverter, especially used for utility or large scale solar power plants. So it will be in megawatt range. So single solar inverter will mostly in megawatt range. Nowadays solar inverters is available in single inverter available in 4 megawatt range, up to 4, or some researchers are going on for 4 and above megawatt range. So then the second type of inverter is called as string inverter. Compared to central inverter, string inverters are available in kilowatt range starting from 1 or 2 kilowatt to 200 or up to 300 kilowatt string inverters are available. So most of the rooftop applications, the string inverters are mostly used. And the third type of inverter is called as micro inverter. So micro inverter, the power rating of the micro inverter will be in watt, or sometime some inverters are available in 1 or 2 kilowatts. For an example, 500-watt micro inverter, 1 kilowatt micro inverter, 1.5 kilowatt micro inverter. So here the micro inverter is used for a specific panel. So for an example, if one 500 watt peak solar panel is available means, so that 500 kilowatt watt peak panel is connected directly to the micro inverter. So for one PV panel, one micro inverter, or two PV panel, one micro inverter, or three PV panel, one micro inverter, or four PV panel, one micro inverter. So based on the reliability, we can go with any of the options. So the reliability means due to any reasons, if one of the inverter is get failed means, so certain amount of power will not be available from that particular portion of the solar plant. So in order to avoid the major power outage at the time of fault, if you are going with the micro inverter, so every one panel or every two solar panel, we are providing the micro inverter. So if any one micro inverter get failed means maximum one or two or three solar PV panel only will get affected. So we can get maximum amount of power from the solar power plant. So it will increase the reliability and as well as the power output from the solar plant. Then moving to net metering. So you might heard about net metering. So net metering is generally called as, suppose if we are having the load, let's say our residential home. So in our residential home, we are planning to install a solar PV system, let's say 1 kilowatt. So suppose if you are after the installation of solar PV plant in our residential home, normally the solar will be available in the daytime. So the solar power normally is used to power the loads in our residential home. So whenever there is no load in our house during the daytime, the solar power is exported to the grid. So in order to accommodate or in order to measure how much amount of power or energy is exported from the from our solar PV installed in our home to the grid, this net metering is useful. So net metering will calculate how much amount of energy we are consumed from the grid. So that is one direction from grid to our residential home. On the other hand, it will also measure how much amount of energy is exported from our residential home to the grid on the another direction. So based on that, we can calculate how much amount of net difference is there. So whether solar is the energy in unit or kilowatt hour produced by the solar PV system higher than the energy consumed by the loads in our residential home or not. So for that purpose, net metering is used. So that net metering is generally called as bidirectional meter. So in this block diagram, you can able to see this is the distribution network is our electric grid, and the consumer panel and consumer load is our residential building. So this part will be our residential building. So we are having some loads in our residential building. So one direction power will come from distribution network to the consumer panel, and the other direction, when the load at the consumer is less, then the solar PV power is exported to the grid. So in order to accommodate that, this bidirectional meter is useful. So in our residential rooftop, we are installing this solar PV system. So up to this portion will be solar PV system, including solar PV panels, then combiner box or DC distribution box, then solar inverter and solar generation meter. Suppose if we want to calculate how much amount of solar power is generated, then we can install this solar generation meter. This meter we can install in addition to the existing or bidirectional meter. So bidirectional meter is mandatory. This solar generation meter is an optional. If you want, we can install, or else we can ignore that. So this is the purpose of net metering. This metering is if we need to install the solar PV system in our residential home, this net metering is important. Without net metering, there is no accountability for how much amount of solar is generated from your house is going to the grid. Suppose if net metering is not there, only unidirectional meter which is there in our residential home alone is there, means the amount of solar power which you are exporting to the grid also will be counted by the unidirectional meter as you have consumed the energy from the grid. So without bidirectional meter, if you are exporting the solar power to the grid, then for that amount, for that solar power also, you have to pay you have to pay to the distribution company, because there is no classification or there is no segregation on the amount of solar data is generated by the solar PV system installed at your plant. If you have any question as of now, please unmute yourself and ask. Okay, I will continue further. Now I will touch upon the solar power in our India. So here in the left side, you can able to see it is a cumulative installed capacity starting from 2010 to the last year 2023. So in the year of 2010, mostly solar PV systems are available in kilowatt range. So that is the time the solar power is booming in our India. So after 2012, it become an important, or it become an alternative to the conventional power plants. So after 2012, the installed capacity of the solar PV plants in rooftop solar PV system in residential system or commercial, any commercial power plant, commercial plants or industrial plants, it start booming, as well as the utility scale power plant. So scale power plant, generally called as the solar power plant, dedicatedly used to produce the power and export to the grid. So that is called as utility scale power plants. So it start booming. So you can able to see after 2015 there is an closer to double digit increase, 3000 to 6000, 6000 to 12, 12 to 21. So there is a increase in the capacity near to the double the values. So presently, in the last year, we are having almost 66,781 megawatt of solar installed capacity in our India. In the right side, it is a solar map which shows that for 1 kilowatt peak panel or 1 kilowatt peak solar PV system, how much amount of energy we can get for a particular day and for a particular year. So here you just refer this the bottom scale, starting from here it is 3.2 kilowatt per kilowatt peak. So this scale is in kilowatt hour per kilowatt peak. So it means for installing 1 kilowatt, sorry, for installing 1 kilowatt peak panel, how much amount of so energy we can get it from the solar. So most of our area, our country is in the yellow, light and dark yellow. So you can able to see for the light yellow, if it is closer to 4. So what it means, if we are having 1 kilowatt peak installed capacity in our rooftop, means it can give almost 4 kilowatt hour, that is 4 units of energy from 1 kilowatt peak panel or 1 kilowatt peak system. Suppose if we are installing 2 kilowatt peak panel, means we can get almost 8 unit of energy from it. So in our India, this is the location where we can get the uh, maximum energy from the solar. So it is a dark orange. Dark orange can able to see it is lying here. It is almost 5 kilowatt hour per kilowatt peak. For an example, we can understand like this. If we installed in this light yellow area, we can get 4 kilowatt hour for 1 kilowatt peak panel. Suppose we installed here, we can get 5 kilowatt hour for 1 kilowatt peak panel. So you just assume for 100 megawatt plant. So for a large plant, reduction in a small energy per kilowatt peak having a significant reduction in the power output from the solar PV plant. So that also, if we install this solar PV system, the life of the solar PV plants is generally 25 years. So in these 25 years, we can assume how much amount of energy we can get additionally if we install higher solar radiation area. And can you able to see some portion of China and Pakistan and Afghanistan. So they are in dark red area. So dark red is almost 6 kilowatt hour per kilowatt peak. So they are getting in those locations, we can get maximum energy per kilowatt peak. About the type, as of now, January 2023, the ground mounted solar PV system, which is including the floating solar and hybrid solar. I will explain what is that. So in this one, we are having almost 53,000 megawatt of power installed capacity in rooftop on top of the building, in residential or commercial office. In rooftop, we are getting almost 8,200 megawatt of installation. And off grid, in previous slide, we have seen the rural electrification, right? So for similar to rural electrification application, wherever the electric grid is not available, there we have the installed capacity closer to 2,200 megawatt. And also solar pumps are there, that also solar PV based pumps are there. So that solar pumps also, grid, some pump are available for grid connected application, some solar pumps are available for non grid connected applications as well. So here, floating solar, I will give some light about floating solar. So floating solar PV power plant, normally, let's assume there is a dam or some water reservoir. So in the water reservoir, we are installing the solar PV panels. And other equipments like inverter or transformer and other electrical equipments will be placed on the ground. Only solar PV modules alone will be installed on the reservoir. So that power plant is called as floating solar power plants. And hybrid power plant is the solar PV plant with wind power plant, or solar PV power plant with bad energy storage system, or any other energy resources. If we are having two energy resources, those plant are called as hybrid plant. So the most common hybrid plant is solar with wind, or solar with battery energy storage system. So everyone is clear as of now. If you have any doubt, you can unmute yourself and you can ask. Yes, there is no questions. I will move further. About the installation of solar PV plant in state wise. So this is the statistics of solar PV system installed in India as of 31st March 2023. So Rajasthan is the leading state which having the higher solar PV plant installed capacity closer to 17,000 megawatt. Then followed by Gujarat 9,200 megawatt. Then Karnataka 8,200 megawatt and Tamil Nadu 6,700 megawatt. then Maharashtra 4,700, Telangana 4,600, and Andhra 4,500. So these are all the leading states which having the higher solar PV power plant installed capacity. So moving further, the major solar power plant in India, Badla Solar Park or Badla Solar Power Plant in Rajasthan, having the highest installed capacity of 2,245 megawatt capacity. It is in Rajasthan, followed by Karnataka Bavagada Solar Park, which having 2050 megawatt installed capacity. Then Karnool Ultra Mega Solar Park, 1000 megawatt capacity. And in Tamil Nadu also there is a Kamudi Solar power projects. It is installed by Adani in Ramanathapuram district. So it having 648 megawatt of installed capacity. So can you see here there is a world called Ultra Mega Solar Park. Any power plant which having the installed capacity of 500 megawatt and above, so those power plants are called as generally ultra mega power plants. So here it is solar power plant. So it is ultra mega solar power plant. So this is the aerial view of the Badla solar power plant in Rajasthan. So here this photo was taken from the Wikipedia page. So the credit goes to Wikipedia. Uh, So here what you are seeing, these are all the solar PV modules. The black color what you are seeing, these are all solar PV modules. So these are generally a large scale utility power plant. So this type of plant generally will use central inverters, that is higher capacity inverters, mostly in megawatt range. Okay. So here can able to see the solar PV panels are installed in a different locations. So each locations generally is called as land parcel. So in simple words, solar PV panels installed in this location is called as land parcel 1. This will be land parcel 2. This will be land parcel 3, land parcel 4, land parcel 5, land parcel 6. Then land parcel 7. So these are all the general terminology used in the utility scale power plant. This power plant will have the inverters, inverter transformers, then medium voltage switchgear, medium voltage cables, then power transformers, then substations, then transmission lines. So mostly large power plants are mostly connected with 400 kV voltage transmission lines. Okay. Then going further, this is the aerial view of Kamudi solar park in Tamil Nadu. And this is the Bavagada solar park in Karnataka. So by seeing this figure, you may get the question. So the solar PV panels are here is there and here also there. So the distance from this panels to this panel, it's not very nearby. This will be in kilometers. So roughly 8 to 10 kilometers difference will be there from this part to this part. Okay. So there are certain challenges were there for conducting or carrying the power from one location to the other location. So in this power plant, generally there is a single or a couple of substation in ultra mega solar parks. So from each of the solar inverter station or solar inverter room, there will be an outgoing cable or outgoing line to the substation. So that feeder, some location they will use the cable, some location they will use the transmission lines, what you are seeing in our road. If you are if you are able to see any overhead transmission lines, the similar lines will be used to transfer the power from one location at the that is the location of the inverter station to the substation. Okay, so now I will touch upon the organization for the solar energy. You might be heard, someone might heard about the Ministry of New and Renewable Energy. It is our central government ministry for the renewable energy. You can able to access, you can able to go through this mnre.gov.in to get more information about the renewable energy. So, and also we are having Solar Energy Corporation of India. In short form, it is SECI. So this SECI normally will give the tender, and it will taking care of installing the large scale solar power plants in India. And also Indian Renewable Energy Development Agency, you can access in this website. And also there is an institute called National Institute of Solar Energy. This is in Gurugram, closer to Delhi. You can access here. So I will go through that website. So there are so many informations are available in those website. If you are new to this website, I'm suggesting you to explore the options or explore the information given in this website. In this figure, can you able to see this is the floating solar power plant. So in here water reservoir, the solar PV panels are installed. Okay, this is the floating solar power plants. So here you can explore various options and various initiatives of MNRE. You can able to find it here. And SECI, in SECI, you can able to find about the tenders, any new project, whether they are what are the new projects they are issuing the tender. Those are the things you can able to get in this SECI website. So in this website can able to see here it is yeah, tendered for 400 megawatt offshore wind plant. I think this is for Tamil Nadu. They are planning to install the offshore wind plant in on the coastal area of Kanyakumari district in on the sea. So I think that is this is for that tender. Can able to see 500 megawatt. This will be mostly the solar plant. 1260 megawatt. This also could be solar plant. This is for 1500 megawatt solar PV plant. Then again one more 1500. Okay, so this information you can get it from SECI. And this is the website of National Institute of Solar Energy. So here also you can able to find uh, various initiatives and various programs. Here you can able to see NISC internship program for BE Tech, MEM Tech. So you can explore about these options as well. So my suggestion is that you can go through these websites once in a week, mostly a Saturday or Sunday. Once in a week, you can go through this website frequently. Then you will get more informations, up-to-date informations. You can explore this one. Then now I will take you through the glimpse of the 300 megawatt large scale solar PV power plant. In this photo, what you are seeing, it is a solar PV panels only. So it's a 300 megawatt solar PV plant. So 300. So in roughly 300 megawatt solar PV plant needs minimum of 1000 to 1500 acres land. Suppose if you are going inside the solar PV model, if you see across the 360 direction, you can able to find only the solar PV panels only. If you are not familiar, then you can go with who is the person is a technician over there. So I got the opportunity to go to a similar power plants. If I am going inside, all the direction only solar PV modules only. So it is not easy to come out uh, easily without any guidance if you are new to this. So in solar PV panels, there are several things are there. I will explain in the coming sessions. Then the installation will be like this. So this is the solar PV module. Here the iron rods are there, right? These are called as module mounting structure, simply MMS. This module mounting structure mostly in aluminum or sometime in iron. So this is a ground mounted solar PV plant. So all the solar PV modules are installed on the ground. So in the floating solar, we can see the modules are installed on top of the water. Here it is on ground. Okay. So in a side view, the PV modules are look like this only. So this is one row. So here you can able to see there are four rows of panels were installed. One, then this will be the second row, this will be the third row, and this will be the fourth row. So this type of structure, model mounting structure, is called as 4P structure. So we can install four panels in a single structure, MMS. It's called as 4P structure. 1, 2, 3, 4. So most of the ground mounted solar PV system looks like this only. So you can able to find grass, bushes across the solar sites. And this will be an inverter room. Here can able to see in the right side there is a building, right? This room is called as a inverter room or inverter station. So the central inverters, what I told, so those inverter in most of the cases will be installed inside the room if it is a indoor type of inverter, or some locations outdoor type of inverter, solar inverters, central inverters are available. Those inverters building like this is not required. We can install the inverters in the outdoor. Then this will be the transformer. This transformer is called as inverter duty transformer or simply solar transformer. This transformer is not a typical distribution transformer what we are seeing in the road. This transformer having some additional features that is required for the solar inverter applications, like withstanding the harmonics, then voltage fluctuations. There are some power quality requirements are there for solar inverter. So those additional features this transformer has. Then after this transformer, there will be an electrical switch gear. So that electrical switch gear is there. So this here you can able to see the panel, right? This is an electrical switch gear panel. Inside this panel, there will be an BCB, vacuum circuit breaker, or some locations SF6 breaker also there. Some location isolators. It's not a circuit breaker, but it's a isolator will be there. So that from here a single output will go to the substation, right? So here can able to see there is a small box over here. This box is called as NIFPS system, nitrogen based fire protection system. uh, so that system in look like this. So that is a bigger one. This is a smaller one. So this NFPAS system control box is this one, and the actual NFPAS system is this one. So for this NFPAS system, we are having the control box inside the room. Inside this room, this control box will be there. So what this NFPA system will do? So the can able to see this is a oil type of transformer. Inside the transformer, there will be an huge quantity of oil. Let's say 2000 to 5000 liters of oil will be placed inside this transformer. Okay, suppose if due to the overloading, overheating will takes place. Due to that overheating, there is a chance for the fire accidents. So the oil can able to melt. So the transformer oil after certain degree Celsius, it will get fire. So in order to avoid that, this NFPA system will be used. Okay. So if you want to become a design engineer to design such a solar PV system, this NFPA system is required for the transformer rating of 10 MVA, or the oil capacity of 2000 liters and above. Those transformer we should have the NFPA system like this. So NFPA system, what it will do, it will monitor the transformer oil temperature. If the transformer oil temperature is high, it will monitor the oil temperature in the bottom as well as the oil temperature in the top. So it will calculate the difference. If any such difference is there, then what it will do, it will circulate the oil. So the hot oil will go out and the normal trans oil with uh, more mean temperature will come in, so that will avoid the fire accident. Everyone is clear as of now? Can anyone turn on your mic and say yes or no?
Yes, sir.
Yeah, good,
Yes,
fine.
sir. Very clear, sir. Thank you. Thank you.
Then this is the NFPA system control panel, and this is the substation. For the large utility scale power plant, there will be an substation to connect the solar power plant to the grid. Here can able to see here there is a transformer. It's a power transformer mostly in 100 and above MVA range. So it will step up the voltage from 33 kV voltage to the 220 kV or 400 kV, and it will connected to the transmission line. So this is generally the called as substation. Here transformer, circuit breakers, circuit breakers, then CT, PT, CT current transformer, potential transformer, it's available. Okay, so here is the structure. Inside the structure, there will be an rod. That rod is called as lightning arrestor. So if any lightning is coming nearby, so this arrestor will arrest that lightning, and it will safeguard our electrical equipments in the substations. And yeah, this will be an display of the solar inverter. So it is 2.25 MVA inverter. So it is having two sessions. So 2.25 divided by 2 is the individual session. So this is the individual session. So 1.125. This will be another 1.125. So combined it is 2.25 MVA inverter capacity. So when this photo was taken that time, the total inverter output is almost 182 kilowatt, and from the section 1, that is power inverter part 1, it is producing 91 kilowatt. In the inverter part 2, it is producing 91 kilowatt, and also it is consuming 8 kilowatt, uh, 8 kVAR of reactive power from the grid. So, from whenever you are seeing a solar power plant or solar inverter, direction is important, because solar inverter can able to operate in a 4 quadrant operation, exporting the solar real power, exporting the reactive power, exporting the real power, importing the reactive power, and exporting the reactive power, importing the real power. But in solar, this is not a ideal case. The third one, and fourth one, importing the real power and importing the reactive power. This also not a ideal one, but it can able to operate. Okay, so this inverter having some auxiliary equipments. During the night time, there will be no solar power from the panels. So that time this solar inverter will operate in the 4th quadrant, that is importing the real power or importing the reactive power from the grid. Okay, so now we came to the end of the presentation. Um I will summarize what we have seen in this presentation. First, we have seen about the application. So we have seen the application of solar energy for the electricity generation, rural electrification, solar heating and solar pumps. And I have given some lights about the solar PV system and its major components like solar modules, solar DC distribution box, solar inverter, then AC distribution box, then solar power in India. Then we have seen the solar installed capacity starting from 2010 to 2023. Then solar map for India. Then uh, we have seen the kilowatt hour per kilowatt peak installation across our Indian subcontinent. Then we have seen the state-wise the solar PV installed capacity, and we have seen about the some of the major large-scale solar power plant in India, and also lastly we have seen the some of the photos of a 300 megawatt solar PV plant, the solar PV modules, the module mounting structure, solar inverter room, then inverter duty transformer, then switch gear, NFPA system, then substation, and finally the inverter display. Yeah, if you have any doubt, please unmute yourself and you can ask your doubt. And this is you can connect to me in LinkedIn this web link. I will share this link in the comment box. You can connect with me either on this. If you have any doubt, you can ask.
Sir, this is Mangeer Karasi from Associate Professor and Head from the Department of Instrumentation Control Engineering, Sivaraman Engineering College. Thank you, sir. It was highly informative. All your slides. Today I was not able to join due to some problem in the registration. So I'll see to it I attend the sessions, all the sessions. Thank you very much. And my question is, one of my students' batch is started working with installing rooftop solar panel that is in the adopted villages under UBA in my department. What are they have started? They have just given the proposal. We need to have we need a clear cut idea about uh, parameters of other than the megawatt capacity of the need. What are all the parameters or the constraints we should look in for when we install PV panels in the rooftop?
So some of the constraints are the first one is shading. So if you are going to install any solar PV panels on, on the rooftop, first one is the shadow free area. So nearby the tree or nearby the building, there is a higher chance for the shadow. So we have to install the solar PV modules in the shadow free area only. So if we install, if the shadow is falling on the PV panel, so it will affect the power generation from the solar PV panel. So you will that will result in the amount of power produced by the solar PV plant, then finally energy from the plant. So that is the one part. Then second one about the statutory requirements. So it including the earthing for the solar PV panels, then earthing for the inverters and AC and DC DBs, then lightning arrestor. So in the existing building, if there is an lightning arrestor, then you no need to worry. Suppose if there is no lightning arrestor in the existing in the building, then you have to install the lightning arrestor. There are three methods are available to calculate the lightning arrestor protection for the solar panels. So in any of one method, you can use and calculate how much amount of lightning, how many number of lightning arrestor is required to cover the entire rooftop area. So that is one thing. Then there are certain guidelines are given by MNRE for the rooftop solar PV system. So those guidelines before you are start installing any rooftops solar PV system, you have to go through those guidelines and accordingly you have to execute. So these guidelines include the MNRE guidelines and uh, CEA Central Electricity Authority. In this Central Electricity Authority, they have some technical standards. So in this technical standard also there is a safety guideline, there is a connectivity guideline. This guideline also needs to meet. Yeah, that's all.
Thank you, sir. Thank you very much, sir.
Any other questions?